In this Play Pause It video, you're going to be asked to solve several different equations and provide their solutions in order to move on through the video. So try this first equation and see how you come up with an answer, and then we'll go through it. So for this one here, this one's a pretty standard, straightforward, and simplistic one. Because t is already on one side of the equation, so the variable's already on one side. There's no like terms to combine together, so it's pretty much as simplified as you're going to get as far as the equation goes. So really the only thing I have left now is to get the variable isolated. And typically when I'm at this point, I'm going to start following the order of operations in reverse. So any additions or subtractions go away first. So since this subtraction of 2 is happening to the t, I'm going to add 2 to both sides, which gives me negative 3t equaling 18. I would then divide both sides by negative 3, and to get that t equals a negative 6. So let's try the next one now. Okay, so this one a little bit, more complicated. As far as simplified goes, it's pretty much simplified on each side. There's no like terms on the left-hand side here to complete. There's no like terms in here over here to combine. But I do have variables on both sides of the equation. So for me to go any further in the solution process, I do have to get the variable on one side only. And it really doesn't matter, it depends on what your decision is, how you're going to handle it, what side you want to put the variable on. But you do have to make a decision and do that. Now, I, for one, and I'm used to putting my variable on the left-hand side at all times, although sometimes that does give me a negative, like in this instance here. I will subtract 8x from both sides and get negative 2x minus 7 equaling 9. You could have also, done the same thing by subtracting 6x on both sides, and you would have had a positive 2x plus 9 and a negative 7 on the left over. So there's different ways of handling this. This is not the only way the way I'm showing you is not the only way of doing it. So, but now at least the variable is on one side of the equation now, so I can start going through the process of isolating it. So I'm going to add 7 to both sides and get that negative 2x equals 16. I would then divide both sides by negative 2 and get that x equals negative 8. Let's move on to the next one. Now this one's even more complex yet because I have x's on both sides, I have parentheses, I have some multiplication occurring to those parentheses, so there's a number of things that have to be done. And in this case here, some simplifying on both sides of the equation should be done before I start trying to move any variables around. Because although it's tempting to try to move the x's right now, anything inside of a grouping symbol should not be moved until you're able to get rid of the grouping symbol. So since both of these grouping symbols, both of these parentheses have multiplications attached to them, I really can't get rid of them unless I find a way to handle those multiplications in some way. And one of the primary ways that we tend to do that is use the distributive property. So I'm going to distribute this 5 to x and minus 4. I'm going to distribute this 3 to x and minus 2. And when I do that, I get 5x minus 20 plus 8, because it just comes along for the ride. 3 times x minus 2 is 3x minus 6. Plus 4 comes along for the ride. So now I got rid of the parentheses. It's still on both sides of the equation. I'm still not simplified yet because of the fact that there are some like terms I can combine. The negative 20 and plus 8 here, the negative 6 and the plus 4 here. So 5x minus 20 plus 8 is the same thing as 5x minus 12. 3x minus 6 plus 4 is the same thing as 3x minus 2. So now it looks a lot more like the one we just did in the previous example. So now I'm going to start, I got both sides simplified as far as they'll go. Now I need to work on getting the variable on one side of the equation. And I'm going to do that by subtracting 3x from both sides. That makes this go away, leaving me with a negative 2 on the right. 5x minus 3x is 2x, and since there's nothing to combine with the minus 12, the minus 12 just stays. Now with the variable on one side of the equation only, I can start going through the process of isolating it. So I'm going to add 12 to both sides, and I get 2x equaling 10. And then I would divide both sides by 2 to get that x equals 5. So the solution is that x equals 5. On to the next one. Now this one here, there's many different ways of handling this. It depends on what your your comfort level with dealing with fractions would be. I mean, I could just distribute 2/3 into this and 1/4 into this and work from there. But I would have to use a lot of fractions and deal with a lot of common denominators and making sure that sort of thing is going on. And sometimes students, when they're trying to remember the algebra, they sometimes forget the more basic computations from arithmetic days. So one of the ways that it's even shown in the textbook what is recommended to do is if I can multiply both sides of the equation by a number that has a common multiple of 3 and 4, hence the previous lesson dealing with the greatest common factor and the least common multiple. If I find the smallest number that 3 and 4 could both go into, and multiply both sides by that, I would at least temporarily clear out any of the fractions. And so 3 and 4, if I go through that process, the least common multiple of 3 and 4 is 12. So if I multiply both sides by 12, I would end up with 8 times y minus 4 equals 3 times y plus 1. So I haven't gotten rid of any parentheses or anything, but the equations are the same. It's going to be the same solution because I did the same thing on both sides of the equation. I didn't get closer to an answer yet. I just made the numbers that I'm working with something that's more comfortable for most people. So now I'm going to distribute the 8 on the left-hand side and the 3 on the right-hand side to simplify. And I have 8y minus 32 equals 3y plus 3. Both sides are now simplified as far as they will go. So now I want to get the variable on one side, so I'm going to subtract 3y from both sides. And that would give me 5y minus 32 equaling 3. Now that y is on one side of the equal sign, I'm now in a position to try to isolate the variable. So I'm going to add 32 to both sides to get that 5y equals 35. And then I would divide both sides by 5 to get that y equals 7. Let's move on to the next one. So this one here, on the right-hand side is pretty as simplified as it will go. I do have x's on both sides of the equation, so I know I'm going to need to, eventually get x moved to one side only. But right now, this side here needs simplified quite a bit. So I'm going to start off by distributing the 3 in this quantity, distributing the 2 in this quantity. So I'm going to have 3x plus 6 plus 2x minus 2 equaling 5x plus 4. Now, I'm going to combine my like terms together. 3x plus 2x is 5x. 6 minus 2 is plus 4. So I have 5x plus 4 equals 5x plus 4. Now, at this point, some people are able to recognize what's going to go on with the rest of this problem. And even at this point here, you could make that recognition and give it an answer to this, which I'm going to mention after I go through the rest of the steps. So if you recognize it here, great, and I'll go through how to explain that momentarily. But if you don't recognize it here, obviously the next step would be to try to get my x's on one side of the equal sign. So I'm going to subtract both sides by 5x to try to move it to the left. And when that happens, it cancels on both sides. And I'm left with the equation 4 equals 4. Whenever I go through the process of solving an equation, and when I carry it through, my variable goes away completely, I have one of two special cases. I either have a special case where there is no solution, or I have a special case where everything is a solution. All real numbers would be a solution to the equation. How do I tell the difference? Well, since this is a true statement here, that means that there will be an answer. So if there's going to be one answer, there's going to be an infinite number of answers. So there are an infinite number of solutions to this equation, or the equation is known as to be an identity. As I said, we can recognize that up here, because if it says 5x plus 4 equals 5x plus 4, we know that. That's no matter what x I put in there, it's going to happen, because I'm doing the exact same thing to x on both sides of the equation. So it doesn't matter what I put in for x, it's always going to give me the same amount on both sides. So at that point, I can make that realization and make a statement about it there. Let's try one last example. Now this one, there's a lot of things to try to explain with this one. There's a lot of things going on with this. Multiple y's on both sides of the equation. So there's a lot of parentheses and stuff. So there's a lot of simplifying needs to go on first. So I'm going to start doing that by distributing. So I'm going to distribute the 3 to this quantity, the 4 to this quantity, the 2 to this quantity, the 5 to this quantity. And now we get 3y plus 15 plus 4y plus 24 equals 2y minus 8 plus 5y minus 10. Then when I combine like terms, I get 7y plus 39 equaling 7y minus 18. At this stage, people might even recognize what the answer is going to be to this right here. And the reason behind that is that we're going to eventually show there's no solution. And the reason being is, well, 7y is going to be the same regardless. Okay, so 7y is going to be a number. Once I choose what y is, 7y will become another number. But that number is on both sides of the equation. Well, there's no number that I know of that if I add 39 to it, it's going to have the same effect as me subtracting 18 from it. Those should be two different values altogether. They certainly should not be equal. So if you use that kind of logic, you can even state it right here. If, however, you don't recognize it here and keep going through the procedure, you can reach another point where the no solution will be the best and only conclusion you can make. So let's keep going on with it now. Now that both sides are simplified, the next thing I would tend to do is try to get the variable on one side of the equation. So I would subtract 7y from both sides, which of course makes them cancel. So again, I have a situation where as I go through my equation solving process, the variables cancel completely. So I know it's a special case. And the two special cases we have are either infinite solutions or no solutions. Well, we saw in the previous example that if I ended up with a true statement, that shows me it's an infinite number of solutions. The final answer I have here, or the result, I have 39 equals negative 18. Well, 39 does not equal negative 18, so this is a false statement. And because that is a false statement, the equation does have no solution, and the equation would be known as a contradiction. And that is the end of this video. If you have any further questions, please make sure to reach out and ask me about it. Until next time, have a good day.